Following on from the previous video where I talked about the script panel, this is using BDD 6502 to help test the grid. For those of you who haven't watched it, quick introduction. I've got this puzzle game here. There's a 6x6 grid, but internally in memory I use an 8x8 grid for various optimization reasons. And I'm going to continuously develop it because I need to get my compression down because it's for a 4K entry. And so I want to make something that will continually test to make sure I don't break the unpack feature. And previously I showed using the script panel to interactively debug it. This is going to be a different method. In order to do this, we need to make a test case, funnily enough. So in order to make the test, we need to make a new directory called features. Just make a new folder. Features, and we'll make a new file inside of here. Map unpack dot feature. We'll open up what I wanted to do. And this is registered as Gherkin, you can see down here. First we make a feature. Then we need to give it a scenario. This is the unpack scenario. Then I have a simple overclocked 6502 system. There is actually a normal, not overclocked one, which tries to run at 1 megahertz. I don't see the point personally. This is just 6502 and 64K of RAM. There is no VIC, there's no timers, there's no data port registers on 0 and 1. There's no banking, there's no ROM, nothing. Just 6502 and 64K of RAM. And I need to load in my PRG. I need to load in the labels. The labels have to be in Acme format. I use TAS obviously. I just wrote a VBS script to convert TAS into the base Acme format. It's not that complicated. And then I want to give it a custom map. There's no point in relying on what the first map is. I'm going to change that a lot. So I'm going to insert a custom map for testing. So I write the following hex bytes. Just 0, 1 to 5. It's pretty straightforward. Let's go through the rest. So now I have a known map. My map conversion function takes X as the map to unpack. So I want this to be the first one. So I have to make sure my register is set to 0. And then I call it. We give it a large number of instructions. That's a little bit silly, but it proves the point. That is just a protection against an infinite loop case. So this way the test will still exit and then it will just fail. So now I need to check to make sure it's done what I expect. So I want to start comparing memory at the active map data. That's where it unpacks to. And I need to assert that it has these following hex. So the first row is all 08s. That's my empty char. It's a bit unfortunate I have to use 08 and I can't put the labels, but how it works, fortunately. And then, 8, 0, 1, 2, 3, 4, 5, etc. And that's the script. That's all it needs to do. Now we can just go and run it. There we are. We have one scenario, 9 steps, and it passed. So, what would happen if it doesn't pass? Let's just give it a fail case. See, this will fail now. Yep, we failed. Address 5A was wrong. Expecting 1, but it was actually an 8. It's going wrong. How can BDD 6502 help me debug and understand what's going on? The first thing we could do is actually dump the whole map if we wanted to. So I can put this here, and we can just do some dumps. I'm not going to do the whole lot. I'm sure you'll get the point pretty quickly. We just do that, and I run it. Now you can see this is what it found, and the addresses. Now, it's a little useful. It'll help you see perhaps somewhere else where it's going wrong if the tests don't quite catch it, but the real help is the trace command. And I enable trace with, I prefer with indent, but in this case the function doesn't call any subroutine, so it's not going to make any difference. And so now we get a full list of what the machine does. So you can see here where we're clearly clearing it. We get the A register, the X register, stack pointer, the flags. All the codes is labelfied, not always labeled correctly, of course. Depends on what you feed into it. But so here we're clearing the map. You could, if you wanted to sort of remove the setup, you could do I run for so many instructions until, and say, map plus whatever that distance is, and then it will run. Then you enable the trace, and then you continue to run. If you wanted to, focus on a narrow area. So as you can see, we can load values, and then we can track the INX and the INY values to make sure it does what we want it to do. That's basically BDD 6502. There's a whole host of additional instructions built in if you look at its built-in documentation systems, etc. But this is the high level. In the next video, which I'm again going to pull out to another video, I'm going to talk about how to use asserts to make sure you don't overflow your bounds.